Alright, in this video, I'm going to go over how do you graph a quadratic. Now, quadratics are going to be in this formula. It will generally look like ax squared plus bx plus c. Now, a, b, and c, they are all coefficient. Well, c is not a coefficient, but a and b are coefficients, and c is a constant. Now, as an example, because it might help you to actually see an example of a quadratic, it might look like x squared plus x minus 6. Now you're wondering, where is a and b? Like, you might see that c is negative 6, right? A and b in this case would just be 1. So you could technically write that as 1x squared plus x minus 6. Now, it's literally just the exact same thing, because think about this. What's x squared times 1? It's x squared. So if you don't see anything, it just means there's 1 there. And to graph a quadratic, you're going to need a few certain key points. One of them is called the vertex. So, you know what, let's just start off with a general graph of x squared. So this is generally not to scale, but that is what your general quadratic looks like, and it'll be y equals x squared. Now, we have this graph, and it's not just x squared. It's x squared plus x minus 6. What does that look like? Now, unlike a linear function, where it's in the form of y equals mx plus b, if you've done that before, then that's great, and you probably have done it before if you're learning quadratics. Anyways, you're going to see that the standard form of that is y equals x. Just very, very simple function. It's going to end up looking like a straight line. Now, what is the b value in this case? B is the y-intercept. So, what we'll do is we see x times m, in this case m is just 1, and plus 0. So that's why it looks like this, because you know that the slope for that is just 1, and it intersects at at the y value of 0. And you know that the y-intercept is at 0. So, that's why we can just graph that function. I'm sure you've seen it before. So the general form of a quadratic is y equals x squared. And it's going to intersect at the exact same point right there. Now, why is that? Because c in this case is actually still going to be the y-intercept. But when it's in this standard form right here, that's really all you can get out of it, other than a reflection, which we'll talk about later, and a vertical stretch. So if reflection and vertical stretch are words that are all new to you, then I'm gonna quickly explain them right now. Basically, a reflection is if a is negative. So if you have negative a, if that a was negative right here, then it's gonna end up looking like that, and it's gonna flip upside down. So that's something you gotta know. And if let's say a, it wasn't just 1, because in this case a is 1, but if a was 2 times x squared, then instead of having just a normal parabola shape, it's going to still look like a parabola, but it's going to be a vertically stretched parabola. So that 2 means it's being stretched. It's going to look extra skinny like that. So you notice how that one's a little bit wider, that one's skinnier. And let's say it was 3x squared, it's going to be even skinnier. So that's what that's going to do right there. You know, it's not really to scale. It looks like it's slightly above the like the x-axis there. It's still touching that point, just like not really to scale. Now, let's go back to our example right here. This all looks messy right now, but that's just because I have multiple graphs on the same thing right there. So ignore the messiness, but understand the concept behind it. And if you don't right now, it's totally fine. You will get it later. Just honestly, the best way to learn is to watch a video or use ChatGPT to teach you things, even though it can be wrong sometimes. I find ChatGPT very well to teach. But anyways, like, the best way to learn is to go ahead, learn something from whatever resource you actually like, from your teacher, from YouTube or whatever, and then just do as many practice problems as possible. So let's run through this practice problem together so you actually know what to practice. We have the equation x squared plus x minus 6. A parabola, I'm going to redraw the parabola right here. It has some key points. So it has something called an axis of symmetry. And the axis of symmetry in this case will be at x equals 0. That straight line. Now, why is it an axis of symmetry? Well, it's because if you take this side of the graph and you flip it over that way, it's going to be the exact same. Same with that. If you flip it over that way, exact same. It's symmetrical along this line. Now, to find this axis of symmetry, you can use the equation x equals negative b over 2a. And we can get these values from, what is b in this equation right here? B is 1. So we can say x equals negative 1 over 2, what is a? Times 1. So x equals negative 1 over 2. Negative 1/2. Let's start graphing this right here. So typically, we will have it at x equals 0. In this case, we have the axis of symmetry at negative 1/2. Next step what we're going to do is we're going to find what's called the vertex. The vertex is going to be at that little turning point. See how it goes down and it turns back up? That's the vertex. It's the maximum or minimum value in the parabola. Vertex right there for that, right there for that. Just understand that if you see a quadratic, that will be the vertex. Anything at maximum or minimum. So right there, that's the maximum. And right here, that's a minimum. So, in this case, to find the vertex, what we can notice is the vertex is actually at the axis of symmetry. And what can we use from that? Well, if we know it's at the axis of symmetry, and the axis of symmetry in this case is negative 1/2, when x equals negative 1/2 specifically, x equals negative 1/2, then what's going to happen when we put negative 1/2 into this equation? Well, we're going to get a y value because that's what a function is right there. It's y equals, or f of x equals if you've heard of that before, but y equals this expression right here. So if we put negative 1/2 into there to find y equals negative 1/2 squared plus negative 1/2 minus 6, and we evaluate this, we're going to get a y value at this point. Now, because the vertex is at the turning point, that's going to give you the y value of the vertex. So, we'll take our x value right here, and we know that it's on this line right here because we have the axis of symmetry. But then if we put that in, we're going to find the y value of the vertex. So, let's evaluate this right now. Y equals 1 over 4, because 1 squared is 1, and then 2 squared is 4, and negative, when a negative squared, you're going to get a positive number. And then minus 1/2. What is 1/2? Well, 1/2 is also 2 over 4, because we're trying to get common denominators. And then minus 6. What's 6 times 4? 6, 12, 18, 24. Minus 24 over 4. Now, 1 minus 2, that's negative 1 minus 24, negative 25 over 4. So, that will be approximately 4, 16, 20, 24. That's going to be around at 6. So we're going to roughly sketch this. This graph isn't going to be perfectly accurate or anything, but that's going to be roughly around negative 6 right here, let's say. Now, is this graph right here, x squared plus x minus 6, is that reflected? A reflection means that if a is negative. In this case, a is positive, so we're going to deal with a normal looking quadratic right there. And typically what you can do is you can, if you want to get it fully accurate, is you can just take points in the graph. Let's say you want to see where is y when x is 1. Then you can put another value in right there to get really accurate points. But if you just want to do a rough sketch, we can see that a is 1 in this case, so it's not going to have any vertical stretch. It's not going to look thinner, or it's not going to look really wide. So we can just say, okay, it's going to look like a normal parabola, and it's not stretched. So we can roughly do a sketch like this. And again, if you want it perfectly accurate, then you can just plug in points in your function to find it. But that is generally what our graph is going to look like right now. And yeah, hopefully this taught you a few things about how do you actually graph a quadratic. It might be kind of confusing at the start, but I'm sure after enough practice you will get the hang of it. And yeah.